Welcome back. Today we'll be solving a question called balance a binary search tree. It is frequently asked question on Facebook interviews and also asked in Amazon. Given the root of a binary search tree, return a balanced binary search tree with the same node values. As there is more than one answer, return any of them. Let's remind ourselves what is a balanced binary search tree. So a binary search tree is balanced if the depths of the two subtrees of every node never differs by more than one. Let's take a look at the example. So here we have an example of unbalanced binary search tree. So you can see that all the nodes are on the right and we don't have any left nodes. And here's an example of a balanced binary search tree. And also these two trees are also balanced because the difference between 4 and the previous level, 1 and 3, is only 1. And if the difference is never differs by more than 1, then it is also a binary search tree. All right, so how to approach this problem? Our input is an balanced version of the tree, and our output should be a balanced version of the same tree. It's nothing said in the problem statement about the fact that we need to do this in place. And it means that we can actually just traverse the tree and add all the nodes to the array. And after that, we'll be able to build a new tree from that array. You'd probably asked how to build a new tree, a balanced binary search tree, from the array of nodes. So if you take a look here, that you can see that in the balanced versions of our tree, the root node is the value in the middle. So it's not the 1 or 2 or 4, it is 2 or 3. So we have two possible scenarios here. So the idea is that we will be taking the middle element in the array, placing it as our root, and then building our tree to the left and to the right. And on each iteration, we would do the same. We would always pick the middle elements and build our tree. All right, let's code it. In the main function, we initially would create a guard statement to just see if our root is a nil. Then we would create our empty array of integers. And then we can just traverse our initial tree. So we would take the root of the tree and pass an array of nodes as a reference. And then we would call other function, which we would later implement, called build balanced BST, and we would pass node array, left and right pointers. Left would be 0, right would be node array count -1, which is the length of the array. All right, let's implement a traversal function. Function node traversal. We'll pass a root node and optional, and we would pass a node array as a reference in out array of integers. In the function, initially we would check if the current node is nil or not. If it's nil, then we would just return. If it's not, then we would call the same function and go to the left in our traversal. Node left, node array, and we would append the current value to our node array, and we will go to the right. In order traversal, node right, node array. All right, so let's implement our build function. Build balanced BST. This function would take node array, array of integers, also a left pointer, which would be just an integer, right pointer, also an integer, and it would return tree node optional. Okay, so if our left pointer is more than right, then return nil. It means that we finished building our tree. First of all, we would calculate the middle elements. So we would do it this way: left plus right minus left divided by 2. Then we would create a new node, tree node from node array, and we would take a node from node array in the middle position, and then we would build the left pointer of the node, calling the same function build balance bst, and yeah, so here we would pass middle -1, and we would build right portion of our tree, also calling the same function, passing the same array, but left would be middle +1, and right would be just right. And in the end, we return our node. Okay, let's run this code. All right, so both of our test cases are fine. Let's submit it. Yeah, all good, accepted. Thanks for watching and have a great day.